Hello, and welcome to this video tutorial on combustion reactions. What are today's learning objectives? Well, by the end of it, I would hope that you would understand what combustion reactions are. The two types of combustion reactions will balance complete combustion reactions of hydrocarbons and briefly discuss alternative resources such as biomass. What are combustion reactions? These are chemical reactions combining a substance with oxygen. A very easy way of saying this is when we burn something. A combustion reaction is the process of burning something. Hydrocarbons are notorious for combusting. Hydrocarbons are notorious for undergoing combustion reactions. They react with oxygen to release energy. This energy we use to power our cars, stoves, heaters, hot water. They also use the same processes in the chemical industry. So we have our hydrocarbon right here, and we are reacting it with oxygen, meaning this is a combustion reaction. Our products vary depending on our reactants and the environment. We'll always get energy, we'll always get water, there's meant to be water there, and the other things do vary according to our reactants and the environment. I will try to explain this in 2 slides' time. So how does burning hydrocarbons actually even release energy? So the energy released during a combustion is from the making of bonds to oxygen. The energy released, so this is formed when this hydrocarbon ends up reacting and forming bonds between this oxygen. This is what gives us our energy. The greater the number of bonds being made and broken, the greater the energy release. I'll try to explain this using an example. If we compare the combustion of hexane to that of the combustion of methane, we know that hexane there's a larger energy release. Alright? This is because hexane is a larger molecule. There are more bonds being broken and then more bonds being formed between the oxygen. This is why there's a larger energy release. Whereas methane is very small, there are a small amount of bonds being formed with oxygen, hence the smaller energy release. The larger the hydrocarbon undergoing combustion, the larger the energy release. There are 2 types of combustion reactions. Now, depending which one occurs depends on the environment. If we are in an environment and there is plentiful of oxygen, so if it's in a little oxygen sort of a cylinder, we most often will undergo complete combustion, or complete combustion such as in your cars. Incomplete combustion means occurs when there's not enough oxygen. I just said that. Incomplete combustion is harmful. It is harmful. Why so? Because the products, you have carbon monoxide, which is poisonous to humans, and we have carbon, seen as soot, is black dust in water, which is fine. It is also inefficient in energy production. So what did I say in this slide? We identified that the energy release during combustion is because of the bonds being made to oxygen. If there is not much oxygen in this reaction, there are not many bonds being able to form to that oxygen, therefore making it inefficient in energy production. This is why complete combustion is efficient, it is amazing, I guess kind of, and the products aren't as harmful to humans. In the syllabus, we'll be focusing on complete combustions when we are looking at how to write a balanced equation for a complete combustion reaction. So, complete combustion is when there's enough oxygen present. This is when we are combusting hydrocarbon with oxygen, and our products are as follows: carbon dioxide, water, energy. I have a couple examples at the bottom. They are not yet balanced. We have our hydrocarbons right there, our oxygen, our products are our carbon dioxide, water, and our energy. Now, the rule of thumb to attempting to balance them is to focus on your carbons first, then try to balance your hydrogens, then balance with your oxygens. With this device I am using, I am unable to write the coefficients or to balance them. So I would suggest that you pause your video now and play it when you're ready to hear what the answers are. I hope you paused it so you're not really cheating, but if you ended up balancing them, you would find that there's a 2 that goes there and a 2 here. In the second reaction, we have 2, 5, 6. In the third reaction, you have 12.5 right there, 8, and 9. Awesome. Alright, this is a real hot topic. Are we burning our money away? Considering that hydrocarbons are what we burn in our cars and in our houses and everything to produce energy. These hydrocarbons, they come from crude oil. This crude oil is a finite source. It is non-renewable. We get this from the ground, we are using it, and it's very precious to us because we need it to produce all this energy so we can live our lives. Whereas, because we are burning it, there's nothing we can do. Once it's burnt, it's gone, we can't reuse it. Because we are slowly burning it, we are depleting the earth of its crude oil. Soon enough, there will not be any crude oil left. This is why it is very, very important to research alternative resources, such as biofuels. An interesting one that I read up on was seaweed, trying to use seaweed to power our cars as a substitute for the hydrocarbons that we combust to give us the energy in cars. Yeah, and that concludes today's video tutorial. I hope you enjoyed it. If you have any questions, which I'd imagine you would, and I encourage them, please bring them to class, and I look forward to seeing you then. Thank you.